Hello, this is Sabbir Malli. The topic of our discussion in this video is the fundamental theorem of calculus 1. The fundamental theorem of calculus tells us that if function is continuous from the interval a to b, then the net change in the function is given by the total change in the antiderivative of the function from the limit a to b. Let's practice this theorem with some example. So let's say if you want to calculate this integral from starting from point A to 1 to 3 of x square minus 6x, how to calculate the definite integral or the net change of the function x square minus 6 from 1 to 3. First is we have to calculate the antiderivative. If you are not familiar with the antiderivative, please watch this video before how to calculate the antiderivative of a function, especially the polynomial or a constant function, and then come back to this video. So instead of using the Riemann sum, today we will calculate the net change of the function by using the fundamental theorem of calculus, which is this. So first let's find out what is the antiderivative of x square minus 6. Means what is the function whose derivative is x square minus 6. So we have in that video couple of formulas to calculate the antiderivative of polynomial function. So we will begin by calculating the antiderivative functions. The antiderivative of x square is you add 1 in the power, become 3, and you multiply by the reciprocal of the power. This is the antiderivative, or in other words, if you take the derivative of this function, you will get x square. And the antiderivative of a constant is a constant time a variable x. And then you have the limit. We will write down the limit here, 3 and 1. And then fundamental theorem says that the net change of the function is basically the net change of the antiderivative. So you plug the upper limit first, 1/3, 3 to the power 3 minus 6 times 3. And then we put a negative sign, and then we plug 1 into the antiderivative, which is a 1/3 1 cube minus 6 times 1. Here are the antiderivative of this function. The complete detail of these antiderivatives are given in the previous video, which is solely on the antiderivative. Please go back and watch that video to practice these rules. So we would need all these formulas in order to calculate the definite integral of a given function. I have one more example. Let's calculate this. What is the antiderivative of 2 times cosine of x? It is basically minus sine 2 times minus sine x. Antiderivative of a constant is a constant time the antiderivative of the function. The antiderivative of cosine, you can see from here, is a negative sign. We don't need to write a constant in this question, because the fundamental theorems do not require the constant, because the constant cancel to each other. And what is the antiderivative of 4x square? It's going to be a 4x to the power 2. You add 1 and then you reciprocate that power. So it's going to be a 1/2 x square. And then we will write down the limit here, 0 to 1/2 pi by 2. So if I plug the upper limit, it's going to be a 2 sine pi by 2. Minus, this is a 1/2 4 is basically 2 pi over 2, the square of that, minus lower limit, upper limit minus lower limit. So lower limit is 0 to sine 0. And if you plug 0, 0 square is again 0. So this is a whole entire thing is 0. Let's simplify. Sine pi by 2 is 1. So this is a 2 minus this is a pi squared divided by 4. And that 2 will cancel out. This is going to be a pi squared divided by 2. And sine 0 is 0 and that's 0, 0. So this whole entire thing is 0. So net change in the function is 4 minus pi squared divided by 2 after the simplification. Here I have one quiz problems for you to practice. So what will be the definite integral starting from -1 to 2 of this polynomial function x square minus 3x minus 18 dx. Once you complete the problems, you can leave your answer uh, in the link above. So to practice this problem. I have a next example to practice on to calculate what is the definite integral from 1 to 4 of this function. As you can see that this is the quotient of two functions, but we do not have any rule to calculate the antiderivative of a quotient function. So the first rule is that when you have a quotient function, we would like to simplify that function. So we will begin by dividing the denominator to each term. So it's going to be a 5x to the power 2 divided by x to the power 1/2. And this is the square root of 1 is basically x to the power 1/2. This is x to the power 1/2 minus 3 is the x to the power 1/2 and dx. So now I will simplify by taking that term into the denominator. So this will be 5. So x will be 2 minus 1/2. The exponent power will subtract. This is simply 1 and this simply 3x to the power -1/2 dx. Now this will be one more step of simplification. This will be 5. This will be x to the power 4 minus 1, which is a 3/2. This will be -1 and this will be minus 3x to the power -1/2 dx. Now let's calculate the antiderivative of the function and then plug the upper and lower limit. So antiderivative of this function is a 5 is a constant and we will add 1 in the power. This will become 5/2 and then we reciprocate the power. This will be 5. The derivative of the constant is the constant time the variable, just antiderivative of this function is just x. The antiderivative of x to the power 1/2 is again we add 1 into the power, which will give you 1/2, and then we reciprocate the power, which is just 2. The reciprocal of 1/2 is 2, and then lower limit to upper limit. Let's simplify a little bit. So this is going to be 5 cancel out. This is a 2x to the power 5/2. This is a minus x. This is a 6x to the power 1/2. Upper limit, then lower limit. So we'll write the rest of the calculation here. If you plug the upper limit and then you plug the lower limit, then we will subtract upper limit minus the lower limit. Pause the video for a minute and do these calculations and come back to the final to see the final result. So after plugging the upper limit and lower limit, and simplifying the numbers, I get my answer is a 53. And you can also verify these calculations by doing yourself. Let's move to the next problem. So my next problem is a word problem. You say the water is leaking out of the bottom of a storage tank. The rate of the flow of the water is R of t, and how much water is lost from time t is equal to 5 to time is equal to 20. So the total lost in the water will be calculated by the integration of the rate of change. So total lost will be the integrating, this is as a practical application, integration from t is equal to 5 to 20 of the rate of change of this integral, which is a 200 minus 8t d. So that is our total change in the water from time t is equal to 5 to t is equal to 20, because the water is flowing at a rate 200 minus 8t. So this will be our total change, net change in the water. The antiderivative of 200 is 200t. Antiderivative of 8t square is a 4t square, because if I take the derivative of this function, you get 8t. And then we calculate the net change, upper limit minus lower limit. So if you plug the upper limit, this is going to be a 200 times 20 minus 4 times 20 square, minus if you plug the lower limit, it will be a 200 times 5 minus 4 times 25. After the simplifications, we will, so the total loss in the water will be 1500 after plugging the upper limit minus lower limit. This is, I plug upper limit here, this is a plug lower limit, and I simplify these numbers. So 200 times 20 is a 4000 minus 6 times 20, which is a 400 times 4, which is a 1600. So minus 200 times 5 is basically 1000, minus 4 times 25 is 100. So after simplifying these numbers, I got 500 water will be lost if the water is flowing at that rate. Here I have another quiz problems for you to practice this concept. Here, suppose the f is a continuous functions and the definite integral from minus 1 to 1 dx is equal to 4. If f is the antiderivative of the function and f1 is 1 and f negative 1 is a given, f1 is given, then what will be the value of f at negative 1? Once you complete that problems, you can leave your answer in the link above to compare your answer with the people. Here I have another example to practice fundamental theorem of calculus or its application. In this example, we have a velocity function v of t, 3t minus t is given, and we would ask to calculate the displacement and distance. So the displacement will be the net change and distance will be the total change in the function. So let's start with the problem number 1. What is a net change? Net change is given by this integral. So the displacement is the net change, which is the definite integral from starting from 0 to 4 of the velocity function, because distance is the reverse of the velocity, the antiderivative of the velocity, and dt. So if I calculate this definite integral, this will give me the displacement. However, the distance will be only when the function is above the x-axis. So this will be the total change, which is the absolute value of the displacement function. So the definite integral of this will be 3 t square divided by 1/2 minus 8t. Upper limit is a 4, lower limit is 0. So therefore, this will gives me 3/2. If I plug upper limit, this is going to be a 16, and this is going to be a 4 times 8, which is a 32. When I plug the lower limit, everything is 0. So this is calculation of these definite integral. So if you plug the upper limit, it's a 3/2 4 square minus 8 times 4 minus, if you plug 0, is everything is 0. And this is a 4 square is a 16. 16 multiplied to 3/2 give you 24. and 8 times 4 is a 32, so the definite integral is a -8. So the total displacement of the object is -8. It means the object is going in the forward direction and coming in the backward directions. So that's why you have the negative displacement in the function. Now let's calculate the second part. In the second part, we have to calculate the distance. It means first let's try to plot this function. So as we can say, the graph y is equal to 3t minus 8. It has a slope 3, and so it's going from 0 to 4. And as we can see that the graph of this function, the velocity graph, is always basically is positive from going from 0 to, if I plug here, when the velocity is 0, when 3t minus 8 is equal to 0, so t is equal to 8 third, which is a something around 2 and more and greater than 2. So 8 third is somewhere here. So the graph of this function is the velocity is positive from 0 to 8 third, and then the velocity is a negative from 8 third to onward. The graph is below the axis. So let's first plot the graph of this function, and then we will see that how to calculate the definite integral of that function. So here you see the graph of this function. You can see that the graph from 0 to 8 third is below the x-axis, and from 8 third to 4, the graph of the function is above the x-axis. So if we would like to calculate the displacement, the distance, the total distance will be the definite integral from 0 to 8 third of this function, which is basically below. So I will take the negative sign, put the negative sign here. So 3t minus 8 to make that function positive. And then I will add the distance from 8 third, or the total distance covered by 8 third to 4. So this is a 3t minus 8 dx. That will be the total distance covered by the particle. Because the graph which is below the x-axis, I multiply this negative sign to flip the graph basically above the x-axis. So now this is the total change in the function from 0 to 8 third, and then 8 third to 4 is the total distance covered by the particle from here to here. Now we will calculate these two definite integrals, same as we calculate in the previous examples. And pause the video for 1 and 2 minutes and come back for the final answer. After calculating the definite integrals from 0 to 8 third and 8 third to 4 of the function 3t minus 8 as above, my final answer is a 40 over 3. So this is the total distance covered by the particle starting from t is equal to 0, time t is equal to 0 to time t is equal to 4. As you can see that from t is equal to 0 to 8 third, the particle was traveling in a opposite direction, and then the particle was traveling in a positive direction. The graph which is below the x-axis represents the particle going from right to left, and then from 8 third to 4, left to right. Here I have one more iClicker question for you to practice. This is a question number 3. A silkworm crawled back and forth along a straight line, traveling a thread of skill behind itself as a straw. Its position at a time t is given by x of t. Start from t is equal to 0 to t is equal to 10. What is the total length of the thread of the silk produced by the worm? So take a 1 and 2 minutes and leave your answer in the link above to compare with your answer with the others once you have. So this is all I have in this video. Thanks for watching, and